All right, welcome everyone to the Dorman training, lunch and learn. Today we're doing parasitic draw and battery drain. One and the same, but you can see a couple of different things as we go through. My name is Truglia. I'll be your instructor today, as usual. Tomorrow, I want to remind you to heavy duty. We have Sweet and Owen on, so come on 12 o'clock tomorrow for heavy duty. You're always bound to learn something. We'll be about an hour or so long today. We're going to go over essentials behind parasitic draw and battery drain issues, with tools to use, range of diagnostic strategies, repair methods, and case studies. So, what is parasitic draw? Basically, it's when someone's battery is pulling current from something that is still on, right? Now, a lot of you may have different types of ways of doing this. We'll go over those different methods. Tools to use. So the old days, we did a test light, because what was on a vehicle? Nothing much years back. And if you seen the little bulb light up, you had a problem. Well, you had that big AM radio in the car, and if it was a super duper vehicle, you had a clock in there. Those were a couple of the things that would cause parasitic draw besides an alternator. And years back with the generator, you wouldn't have that problem because it did not have diodes. So this way, you can't tell how bright that bulb is, right? It's close to impossible to say how bright it is, how much voltage it's using. You can't tell. So the next best thing is putting your meter in series as pictured here, and we're going to go over this. I'm going to show you this thing right here. This is a 10 amp circuit breaker, which is a lot better to use for the simple reason the fuse will blow and you'll have to keep getting new fuses. There is a problem when we do it that way that we'll speak about in a second. And an amp clamp. Now, the pictured here is an ADI-110 amp clamp. The problem with that is that clamp cannot fit around every wire. When you're using an amp clamp, you want to go around all the wires, either on the negative side or the positive side, to make sure you're grabbing the right amount of current. Now, a couple of different things here. Checking parasitic draw with a DVOM, two different ways. Well, this old picture here, courtesy of Fluke, you basically open the circuit up, the black lead, which is your common. You take the common, go to the negative side of the battery. You take the red lead in the 10 amp jack and go to the cable you removed. And then you would measure the current draw. Now that is the most accurate way, no doubt, but here's the problem. If you exceed 10 amps, well, you're going to burn that fuse out without using that circuit breaker, right? So there's another way that I'm going to show you here. And there's a few different ways, but this is the most reliable, most accurate if you kept the battery power alive, and we'll discuss that in a second. Now you see this here? If you get a 1 ohm 10 watt resistor and you go from your meter voltage leads in here, the reading you'll get on millivolts will basically give you the current flow. It would convert voltage to current. So let's say you had 100 milliamps. You would have a 1 amp draw. Does that make sense? So that is something that you can do as well. Besides, you're going to need a 1 ohm 10 watt resistor to bring down capacitors in computers. You don't want to just touch the two cables together like this, because that would be a no-no, right? Capacitors don't like that. And years ago we did that, but you didn't have computers on cars when we did that. So if you look back and you actually, think what we did, well, you didn't have, again, a computer. Today's vehicles have computers. And if you're on a hybrid or an EV, if you short a capacitor, it would be a big explosion. Why? Because those capacitors are a lot bigger. Does that make sense? So whether it's a little explosion or a big explosion, it doesn't matter. You shouldn't do it. Let's see what we got over here. So basically, it shorts a resistor. Yeah, so you want to bring a resistor down slowly. You don't want to short the resistor out. You want to bring it down slowly with resistance. Now here's something on the Snap-on Vantage. You know, they're going to tell you how to perform it. Open the circuit up, because you're going to have to let current flow through the Vantage in this case. And you see the open right here? That's the open circuit, and then you would measure it. Okay, so when just-in-time training that was put inside Vantages, or the new style Zeus and Vantage and other Snap-on stuff, there's information in there if you're not sure how to do it, okay? When we did it this way, we said with the fuse, this is pretty good, because if the fuse blew, or again, use the circuit breaker if you're pulling more than 10 amps. The amp clamp is real good, but let's talk about the amp clamp for a second. A few things with an amp clamp. You need to put the amp clamp close to the wire first to zero it. If you don't zero it there and zero it all the way out here, or try to zero and when you're around the wire, you're going to get the wrong reading. For the most accurate results, you want to be near the wire for the magnetic field and zero it there, then put it around the wires, okay? Now this is the best, this amp clamp right here that we're going to be talking about. This thing is the cat's meow. And no, I'm not getting paid from Fluke to tell you. This is what we use. It is a, maybe come in on the darkness here. There we go. It is an I-30S. Be careful, they make another clamp that looks real similar, but I-30S, and you can see up here on the screen, this yellow amp clamp to the left is the Fluke I-30S. That is the best amp clamp to use because of the size of the jaw that fits around the battery cables. Specifications, DC range is 30 milliamp to 30 amps. So every amp clamp has a range. You may go, well, I have that little PDI clamp, and I'll show you a couple of different clamps here. You know, you may have this clamp for argument's sake, or this clamp. Okay, this is not going to be, number one, the jaw is not big enough, it won't be accurate enough. This is for starter drawer. This would not be good to use either because of the range. So all of these have ranges where they float or give good accuracy. So in this instance, the Fluke I-30S is the one to use. There's no problem using it on any vehicle for parasitic draw or any battery drain. The amp clamp can read down the 5 milliamps draw with 1% float rate, which means the accuracy is pretty dead on. So even though their spec is 30 milliamps, it is good. You can go all the way down with it. The little floating rate for our business is nothing to worry about. For maybe other electronics, it may be a little different, but for here, this thing is the best. So you may want to invest in something like this, okay, because it's going to make your life easier. And notice this also has BNC, so we can use it on our lab scope, and then we buy the Fluke banana to BNC converter. So we put this in, and that way we can use it on a meter. You don't always need to pull the backhoe out if the shovel will do the job, right? So that being said, excuse me. Now another way is doing a voltage drop on the fuse. The voltage drop method on the fuse here, some training companies went out and did an 8-hour type of class on this. Now the thing to be careful about on this is if you're not on the pins of the ATC fuse here, you got to be dead on them. You're not going to get a good reading. If the reading is floating on the meter and not steady, that's called ghost voltage. And you don't want ghost voltage because it's not accurate. So any good steady reading is basically going to tell you what's going on, that you have something there. Now there's a chart. There is, I forgot the name of the tool I have that, no sound? Test, test. We got sound here. You hear it? Yeah, I hear it. Must be on your side, guy, that you have no sound. But, excuse me, there is something that you got to remember when doing this. When you're trying to be on that fuse end, look what happens when you get to fuses like this, the ones with the covers up top. You can't do this method. And that tool I have, I can't think of the name of the damn tool. But anyway, it has a chart, or you could find a chart online, what every fuse, what the maximum amount of voltage drop would be, because you got to remember, you can't have a voltage drop unless there's a current draw going on. So that means there's got to be some amperage somewhere that is being used or pulled from a component. Otherwise, you can't get voltage drop. Now let's take a look at this little video here on voltage drop. Pay attention to it because it will show you how to actually operate it and talk about the ghost voltage. So here we go. How to do parasitic draw with your voltmeter on millivolts DC. Notice we're at 0. He's on a fuse, but go off the fuse for a minute and show us ghost voltage. So if you got ghost voltage, you see it bouncing around, you're not connected. Like, go near the fuse, but don't hit the metal part. Go near the fuse. So if you near the fuse and you're not on the pin, you're still going to be bouncing around. Now go on the pin. We'll get a solid 0. Now we're going to open the door up because there's no parasitic draw, but watch what happens when you got a load on. There's the door open, the dome light. The dome light is on, the door panel lights are on. Come back around on his car, and we have a millivolt voltage reading. That means we have a parasitic draw. Go shut the door, Solomon. We're still on there. See where we're connected? Now watch this. It stayed there, and look at that. It timed out. Okay? So it has to time out. Sometimes it'll stay up longer than others. So still doing some bouncing around, right? Stay on the pins. See, he went off the pins a little bit because he was looking. When you see bouncing around, you're off. So watch this now. It's probably going to take, we're starting to drop, 0, 0. Yeah. Now you know it's timed out. How long did that take? Probably 20-something seconds or so, 30 seconds, 30 right? 20, yeah. So this is how you do a parasitic draw, okay, when someone's battery is going down, by doing voltage drop on the fuse. You got to be in to the fuse correctly. So you can see that once the tech went off those pins, the meter floats. And if the meter floats, that's called ghost voltage. You are not getting the right reading. And again, I warn you with the other fuses and stuff in a fuse box, it's really not a good method to use nowadays. So you need to know when you get a parasitic draw, what are some of the things that you want to do? That's what we're going to go over. Now we got this new tool, the Power Probe PPDRAW, that is capable of delivering up to 10 amps continuous current through a smart battery built inside of the unit, right in there, okay? Supplies powers and monitors the vehicle's electrical system for parasitic draw, connects to the 16-pin OBD2 connector, view and records data via Bluetooth on a Power Probe Link app. So, I mean, you know, that is pretty cool. We're going to play with that. We're going to show you that in a few minutes because we'll do some on-car. But I have a question for you. What is the specification for a parasitic draw? Where is it no good? What's the number that you have a problem with? Now, obviously, you should put RTFI in there, read the frickin' information, because every vehicle is going to be a bit different. You know, like a lot of Hondas are 35 milliamps. Some cars may be 40. Some Volvos may go down to 15. You got to know the vehicle that you're working on, okay? So always look up the spec. But I would say today, on today's vehicles, you got more than 50 milliamps, you're going to have a problem, okay? So that should be like your high limit. But go to AllData, go to ProDemand, go to Identifix, go to Motologic. There's where you're going to find what the manufacturer really wants. And I know, yes, sometimes it's a pain in the butt to find in-service information, but hey, you're getting paid to diagnose and fix the vehicle. So you should come up with the right specification. Now, a thermal imager, great tool. In fact, this is my go-to tool when I'm going to do Parasitic draw along with that i30S. You know, when you look at what your meter is showing you or your lab scope is showing you or your graphing meter, yeah, it's showing you current draw, but where is the draw? Now, you could go whack-a-doodle, and today's vehicles have more than one fuse box and play with that voltage drop test. That's real time consuming. And you're going to get frustrated because you'll probably miss a fuse or can't get into one. And do not take the covers off those covered type of fuses. If you take them off, that fuse has been really, I can't think of the word, messed up. I had a word in my head and then it went, so you'll have an issue. It'll be compromised. There it goes. Compromise, see? A senior moment there. Compromise. And I wasn't looking at the screen. It came in my head. Compromised. And you really don't want to do that. You don't want to be jerking around with stuff. So if you make up, and I'm going to show you the tools we have here on the cart that I would use and highly recommend you use for Parasitic draw. But when we look at thermal imagers, before we even get to that part, let's go over a review here of the best way to actually do a Parasitic draw test. And let's concentrate on this meter right here. You're going to put your meter on milliamps, amps. You're going to be in the common jack and you're going to be in the amp jack, right? Now, we're going to go to the battery with the black lead as you see here. The red lead is going through that 10 amp circuit breaker. Now this little piece is not cut off here, so it could be seen in the picture. If you look at the one I have here, the legs are broken off, okay? And I'd highly recommend you get an ATC fuse holder, okay? Put a couple of ends on it, and then put this in series with the lead. So if you go over, all this does is flash off and on. If you put a fuse in there, my fat ass doesn't want to walk upstairs and get the fuses all the time because you'll blow them. And I'll give you a good example on this vehicle, and we'll talk about the clamp in a second. This clamp jaw is too small, right? It's not going to fit around all these wires right here on the negative end. So that's why we're not talking about that just yet. But on that meter, and it's a lot safer, you're going into the voltage jack, you're going into the common jack, and then you're taking that amp clamp, and in this case, we had to go around a small wire, again, because it wouldn't fit there. And you're going to be on a scale 1 MV equals 10 MA, which really means every 100 millivolts equals 1 amp. So every 3 digits on the display equals an amp, right? So let's go over that in a second as well. So this vehicle is pulling 14 amps, 210 milliamps, as you can see on the meter that is directly hooked up, right? If you notice, here's a headlight on my student's pants. So the headlights are on. Each headlight is going to be about 5 to 6 amps. So right there, let's say 5 amps, that's 10. Each little bulb in the back, this had 2 bulbs per side, so they're about 800 milliamps each. Let's count them up and say, okay, equals about 3-point-something amps. Plus you got a couple of park lights up front and a couple of side marker lights. So you can see why we have 14 amps. But what would happen if you put your meter directly and didn't use that circuit breaker? Well, I could tell you what was happening here every once in a while the current went above the limit and the circuit breaker would pop off and have to cool down, and all the lights would go off, obviously, when it's hot, and it'd come back on. But that would be inside your fuse, your meter of the fuse. That wouldn't be real good, would it? A Fluke fuse is pretty damn expensive, right? And again, let's say you use an Advantage, they use regular ATC fuses, you're going to keep changing them out. You don't want to do that. Make yourself that. Again, all it is an ATC fuse holder, 10 amp circuit breaker, and it works perfect. Been doing it for years. Now, let's take the other meter there that's in voltage. You can see how we're connected. The red lead is coming here. The black lead is, the amp clamp is connected, positive and negative. We're on voltage. Now let's look at the display. So if every 100 millivolts equals an amp, how much amperage are we reading? Now this usually confuses everyone, but I'm going to make it simple for you. Let's take the one out of the way and let's just do this. You got 456 milliamps. Let's say that was on your display. That would be 4 amps, 560 milliamps, because every 100 millivolts equals an amp. Now, if you just take the number 1, that's 10 times the amount, okay? Every 100 millivolts, right? That'd be 10 amps. So here you're reading a total of 14 amps, 560. You see the drift? This has 14 amps, 210 milliamps is the exact reading. The amp clamp is not made for that high of a draw. That amp clamp is really made like for fuel injectors, solenoids, and it floats a lot more than that Fluke clamp. So you get what you pay for. Does that make sense? Any questions on that? Doreen, let me know if there's any questions. Okay, now let's take a look here. Love using this one. You got to look under the hood of the vehicle. This here with the black and white floor from years ago, you could see that this is all bright. That is the diodes in there making the parasitic drawer on that particular vehicle. So the parasitic drawer on that vehicle drained the battery down and killed it. Now, we had one in here, I think maybe about a year or so ago. When you look with a thermal imager, this one did not show you any bright light or parasitic draw on the thermal imager from the front of it. We had to put the vehicle up and go from the back to actually see it. So make yourself a note. Don't just look at the front part. Look at the rear as well, because sometimes the case up front, like in this case here, this part here is not lit up, but the back is. Okay, so take a peek at that. Got a question?
Yeah, what is the name of the inline fuse or circuit breaker called again?
It's an ATC fuse holder. So ATC fuse holder. You could buy those online. You can get them from Napa. You can get them from O'Reilly's. You can get them from AutoZone. Just about everywhere has them. Then get yourself a couple of ends, and when you get the ends like this again, you make them up. It fits real easy, because then all I got to do is put it on my lead like this, and then I can go and connect. Okay, that way I'm not burning anything up. Some companies make a fuse piece that goes in here. They unscrew in the end of this, but it's a fuse again. It's going to blow. This is your best thing to do, okay? And if it's too tight of a spot for this, which I doubt, but if it is, you can downsize it to a smaller clamp or whatever. So don't be alarmed at that. Okay. Now this is a big problem I want you to write down. You notice everything else is dark in the background. This is real common. And, you know, I've used this in quite a few different classes because it works and it's real. And we've seen it many times on Hondas and Acura vehicles. That is the air condition relay. So please write that down. It's the air condition relay. 9 out of 10 times, it's only the relay that goes bad. I guess because of the compressor clutch, it gets the relay weak. When the relay is weak, then you get that parasitic draw. It will drain that battery down and kill it. Now, if you put a good brand new relay in and it still lights up like a Christmas tree, then you need to know that that problem is in the AC compressor clutch. But let's talk about the real world. You buy the guy an AC compressor clutch, you put it on, and now the guy has an AC leak and is going to be bent. He's going to want his money back from the clutch because, oh, well, you put it on there. So here's what we do. The vehicles that come in with these type of problems got 70+ thousand miles on them, right? So the best thing you want to do is sell them a compressor and a receiver dryer. And of course, if you want a warranty on a compressor, you're going to need to get an expansion valve, right? That's how everyone warranties their stuff. They want those components replaced. But you're not going to have a customer come back on a hot day being real ticked off at you. Remember, we're the professionals. We have to tell them, hey, this thing is a problem, and if I take your clutch off, you know, it's going to disturb these really poorly made compressors. They really can't take the abuse that the old type compressors did. The York, the Tecumsehs, the A6 units, the V compressor from Chrysler. Those things were heavy duty. They were easy to take a seal out, put a new seal in, put a new clutch on. These new ones are not going to be like that. And one thing people don't want is to come back and see you, especially on a hot day. Question, Dory?
Yeah, how do you check relays using a voltage drop?
Relays using a voltage drop, I wouldn't recommend it. You use a thermal imager. You know, we're in this business to make money. You got to spend some money. A thermal imager, you can still get some launch ones and some Fluke ones, a Fluke VT4, for example, somewhere in the $400 or $500 range. I think Top Don also makes one in the range, maybe $400 to $600. Like I said, launch, I have that one. You don't need something super expensive, but you need the tools. You know, you had a wrench, an open-end wrench, a box wrench. You bought a socket, you bought a ratchet, you bought an air gun, you bought an electric gun. They all do the same thing, right? You spent money on them. You need the right tools to do it. You don't want to try to do a voltage drop on that, because once you lift that relay up, you may unconnect it. You know what I'm saying? The contacts will not be stuck together anymore. And there is a relay that's on, and there's a relay that's off, okay? A good comparison. So here was a vehicle that came in with a parasitic draw, 2010 Honda Odyssey van, dead battery. Now this is also a common problem. And I'm going to tell you why this is a common problem. Where do people let their kids out? On the right side, and that door is always opening and closing. Maybe if the left side door motor's bad, you better maybe check out CPS, right? Because they don't like their kids. So it's not going to be the left side. 9 out of 10 times it's going to be the right side motor. But if you didn't have a thermal imager and you jerk just with the motor, you're probably not going to fix the vehicle. Because if you look here, here's a baby amp clamp on the bottom. Okay, once we seen the i30S up front still having a problem pulling, because I think it was pulling over 2 amps originally, went down to about 150 or so. Well, this little inexpensive amp clamp we put in the back here, you can see it's the trunk lid area, we're pulling 146 milliamps. This is not the motor, this is the computer for the motor. So again, with a thermal imager, you find the problems. Without it, you may just miss the problem. Does that make sense? So to be effective at diagnosing and fixing parasitic draw problems, you're going to need these tools. Okay? So note We found the right sliding door motor assembly and the rear body module. Using a thermal imager led us to the repair. Always trip all the doors, hood, trunk, glove box door, besides making sure that the vehicle is cold for best results. So what we do is pull the vehicle in, and Bill will trip the doors. He'll pop the hood if it has a bulb, take it out or trip it. Same with the trunk. Anything that has a load, you want those loads off. And let's not forget, don't keep key fobs too close to that vehicle, because they may be going back and forth and cause a parasitic draw. So it's a good idea to either use some tin foil to keep it away, or an Easy Pass bag. Easy Pass is our toll pass here in New York, and that kind of helps. We looked at this last month, but for those that maybe weren't on last month, this is a proximity sensor problem, and you could see Bill and I going around. At the time I had a broken ankle, going around this vehicle. It was to the dealer. They sold her a new BMW battery, which went dead. They sold her a new alternator and charged her a bunch of money, but didn't fix her problem. In fact, the lady did not want us to warranty the battery. I don't know why, but she didn't. She was pretty cranky at them. We winded up putting a Napa battery in there. So take a peek. We got a 2012 BMW X5. We have a parasitic draw. We're going to go look at the back of the meter. We're going to come back to this door handle over here. Let's take a look at our meter. And our meter is showing us 268, 269. That is actually 260 or so milliamps. The maximum on this
40
should be 40. And Bill is the guy who is working on this puppy. There's Bill. I am just taking the picture. We need a little light here. Here's the i30 amp clamp, i30S by Fluke. This has a new battery sensor end here on it and a new battery in it. So let's take a look with a thermal imager when we have that type of parasitic draw. We're actually going to look at the screen here and notice it's pretty much all blue, which is cool. If I put my fingers here, you see the difference in the color? And you can even see that the print will remain there. So let's look at the problem area on this X5. And again, there's our amperage. So we're going to be pulling quite a bit. This should light up real well. So here's this door handle. Look at that problem. So that door handle is basically causing a message to come on the display that says
increased battery drain.
Increased battery drain. Perfect. So you can see there, a thermal imager really makes a big difference. That'd be very difficult. How are you going to do a voltage drop on that? It's going to be very tough, right? So that's why having the right tools, why we're successful. We get a lot. You know, if we don't get 4 of them a month or better, I'd eat my hat, okay? Because other shops bring us parasitic drawers as well. And it's a big thing as vehicles get older, people add a bunch of junk on their vehicle, you know, extra components and stuff that they shouldn't. There's a problem. Now, look at this Volvo. Here's an example of a parasitic drawer gone wrong. My guys had put a new battery in this vehicle. And when they put this new battery in, they followed the directions here on Snappy. Let's see what the Zeus kind of told us. Okay. So right here, information about the vehicle power supply can be found in both the central electronic module and the battery monitoring sensor. With the service, stored power supply information is reset. Warning, reset to 0 should only be performed when replacing a battery. Ignition on, engine off. In order for the battery monitoring sensor to calculate the battery correct charge voltage, the vehicle must be off for at least 4 hours after resetting. In some instances, it may require the car to be off for 6 hours. This is on This is on the condition that the ignition key has been removed, all doors and lids closed, and the vehicle is locked. If charge level is low, the brake energy regeneration feature and stop and start features will not be permitted. The battery requires charging. So this vehicle wasn't even a start-stop, but it was not a vehicle that's a hybrid or anything weird. So my guys did this. The lady waited around, it's an older lady. She put it in. Well, this battery went stone dead and would not accept the charge. Totally dead. Okay. Now, if you don't reach out to touch someone, not like that, reach out and touch someone, we use the Opus IVS. You've heard me say that many times, and not a commercial for them, just the real deal that maybe you should take a look at. We contact their Volvo technician, and he says, oh no, you got to wait 8 hours. Okay, if you don't wait 8 hours, it's going to drain the battery down. So there's a big parasitic draw, and we don't know what we don't know. And I'm not ashamed to say, hey, I don't know everything, right? No one does. Only God knows everything. So none of us are God, and we need to reach out to different people. So when we reach out to different people, you find that information out. And my job as an educator and instructor is to help you make your job easier so you can diagnose the vehicle correctly. But don't think it's all like everything. Okay, this webinar is free, courtesy of Dorman training, right? But you need to spend money on everything if you want to be successful. It's just the way it is. You can't do things without it. So here, this battery came in with a weak battery and complaint of hard starting. You think replacing it? Well, maybe, but a straightforward battery replacement and coding should be easy. No. If you think that you just code the battery and send it on its way, or even follow the scan tool information, the battery will have an issue. Volvo states that this vehicle must sit 8 hours. The fix was going to the customer's home and performing the reset after 8 hours. And I want to add something there. We told her to wrap her key fobs in foil and try to keep them as far away as possible from where she had the vehicle parked. So think about that as you're going through. You need service information, right? All data, Motologic, Identifix, and all data, I guess, right? All data, Pro Demand, Identifix, and Motologic. You need that. Okay, let's go to the vehicle part over here at least. Let's talk about some of this stuff. Well, first up, here's what we use for years, right? If you're going to use your meter, we're going to take it and be careful. Always pull out when you're done, almost ready for your bill. And you're going to go into the negative or common jack, and you're going to go into the 10 amp fuse. And then you're going to put your leads in series with the cable that you remove. So negative to the battery post, the red would go there. We're going to use this in series, right? We're going to go like this, and then we're going to have it like this. Now, when we do this, we disconnected that battery cable. Well, if you just had a relay that was sticking, you're done. So you see the battery pack I have here? What you need to do with the battery pack is take the black lead, put it to a good ground, and the red lead put over on the top of the alternator power wire going in. Now, Doreen, I don't know if you can get a shot if you move up. And Bill will point it out to you right over there.
Let me get there.
So if you put the battery pack power lead on that, perfect. That's where you would keep everything alive. Then you would put your meter, you can back up, watch your wire. Then you can put your meter in series and not have a problem. And once you're done, pull out, because if you don't pull out, the next time you go use your meter, you're going to put it on voltage and do it parallel and burn out your meter fuse. So a better way is doing this. Put this in your meter, and we'll show you actually when we're going to make Bill's going to do a drawer in a second, and we could put our meter on millivolts DC, take our I30S amp clamp, put it on, and before we go around a cable, I got a negative cable here, I'm going to zero it. We'll get it close to zero as possible for the sake of time. And we'll take a peek at this here. So that's what we're currently reading. And we're going to play with a new tool here, because I know a lot of you guys are interested. We gave a lot of these away at the TST big event. And I'm going to put this thing on. Okay, it's showing me the battery voltage is 12.6. I'm going to hit this button right here. This should give me the amp draw. So I got right now 3 to 4 milliamps of current draw. You can see that right there. Pretty neat, right? Now, Bill's going to make an intentional voltage drop. So we can look at both of these actually.
Place them down there.
So you see we're pulling about 8 amps. Our voltage went down. And look at our meter. Our meter is pulling we're pulling 6 amps. Okay. Now, of course, if you left it like that, you would have a problem. So this little setup here is pretty neat. I don't think it's 100% accurate with the current, but it's pretty damn good. Okay. So now Bill will undo that, and we'll watch both of these go down. And notice how the meter went right down immediately. And I just followed pretty quickly. And the nice thing with this is it's also a battery saver. Now I have it hooked on an extension cord here, an OBD2 cord, so I can actually have it out here. And I must say, it's pretty impressive, you know, for something that's not super expensive. I think under 300 bucks. So not a bad tool to have in your shop. Bill also used it on a BMW. Now, when you put power supplies through the diagnostic link connector on a BMW, what have you guys encountered out there? And some other vehicles also do it. So type in if you guys have used any battery saver on a BMW. Let's see what you say you came across. What are they saying there, Doreen?
Meanwhile, can you use a jumper cable to reach the alternator, or what if you can't get to it?
If you can't get to it, you can always go down to the starter, any big cable, or if there's jumper lugs on the car. So good question. So where's your answer, guys or gals?
Well,
Where's the
there's
answer?
a delay.
Anything yet?
Wake up the modules.
Okay, not waking up the modules.
The DLC is sometimes a body module gateway. Blown fuses.
Good. Whoever said blown fuses is going to be the correct. So that's pretty common on BMWs and some other vehicles. Some Subarus will do it, a couple of Toyotas. This seems to be pretty good. Did not do any, you know, blow fuse. And a lot of times, if you're not aware of that, you're just going to go change a battery, and you didn't know that putting a battery backup unit on there is an issue, you're going to run into a problem, right? You're going to be going around in a circle. Now let's take a look while this is on here, and there's no current draw. I'm going to put on, we'll use a snap-on one for this. Let me move this out of the way. Let this thing boot up, and we'll take a look here at the current draw. Okay, so I'm going to take this thermal imager, and I'm looking at the fuse box. So Doreen, you need to come in closer. And maybe tilt down. Can you get that screen in there?
Yep.
Okay. Bill, you want to make that problem? So now you see there's really nothing in there that looks lit up like a Christmas tree. But as we have a voltage drop, we should see a color starting to come up.
Yes.
And there it is. I'll probably take a strap. Can you see that on there?
Sure.
This one right up there?
Yep.
Okay. So that is the fuse for the short that we made causing a parasitic draw. Now, isn't that a hell of a lot easier using this thing rather than taking your leads and trying to get on the fuse like this and being on the blades? That is a hell of a lot tougher. And if you look in here, there are a bunch of fuses with covers. So you see all the fuses with covers here? You can't do that on those fuses. Oh, beautiful shot, stay there. But if I go here on top of the fuse, I gotta be able to get on both metal pins. And how many fuses could I do? I can't do them all. So therefore, this is not a good method. It was good in the old days, but not now, okay? So, parasitic draw is something that will definitely affect the vehicle and affect you in your shop, right? Because you're gonna come across, thanks Bill, you're gonna come across these things and you need to know, how am I gonna find that out? So what's the best method again? Trip all the doors, make sure there's nothing on like a light bulb in the trunk, under the hood, glove box, and take the keys, keep them away from it. If you can, you know, make sure you can get it on a lift. That way, if you have that alternator problem that we had seen a while back, looking just from the front down with a thermal imager didn't pick it up, but looking from the underneath this way did pick it up. So thermal imagers, in my opinion, is really what you need. I would recommend these 4 tools that I have here. I'd recommend, first of all, a good meter, like this Fluke 88. I'd recommend the I-30 clamp. I'd recommend a good, in this case, a Snap-on, but there's other ones out there. This is pretty expensive. It does video, but very good. And there's other brands, you know, again, you can get, like I said, Top Don, Autel, Launch. Oh, I think Autel stopped making theirs. Fleur and actually Fluke, okay? So you can buy those. And this is pretty damn neat, because look at this. 3 milliamp draw. I'm gonna leave this here. Let's see if I can open the door for you. See if we can leave that on there. Oh, you know what, I'll turn the lights on. Watch the draw. So the lights went on the vehicle. I think Doreen can show you that. Car headlights. See, they're on, right? Look at the drawer on the meter. And notice how it says the current is still going up. And what happened to our voltage? We went from 12.6 originally, we dropped to 12.2, okay? So a great little tool. You know, it's almost like the other one, and hats off to Power Probe for coming out with something, you know, that is pretty priced in the right range and quite helpful. If it can make our jobs easier and better, hey, that's the name of the game, correct? All right, so I'll open it up to a couple of questions. And anyone, oh, we got a bunch of questions there. So since I don't see real well, I got to get real close to this. I apologize. Yeah, that'd be good. So Bill will be my reader since I can't see real well.
So DJ said, ensure that you know the difference between emissivity and so on when checking with a thermal camera. May throw you for a loop when checking for draw.
Right, okay, so when you're dealing with a thermal camera, and that is important, first of all, the vehicle should be really cold. And when it comes to parasitic draw, we have not had any issues with any problems. We see them all the time. They pop up. So it's not a problem if you keep the vehicle cold. Don't do it outside, don't do it under heat. We'll keep the heat down in the bay, do it first thing in the morning. Again, we always pull the car in, but that is a good point, using it for other things. What else do we got there?
Someone else replied to that, but on real world, any open door would be ignored by BCM after a short time. On newer cars.
Well, sometimes the BCM may not be working real well. And if it doesn't see the door, you know, there's things called load shedding, right, that they shut down. But does everything work as designed? Absolutely not. And that's why just trip the doors. It'll be way better to do it. A decent point, but again, it's better to trip them. Anything else there?
Darren's talking about his approach to finding parasitic draws to use the least intrusive methods possible. That often means doors closed, since many times the problem is in the door to pillar harness on certain vehicles.
Okay. So one guy says, you know, keep the doors closed, but here's the problem. How do you get into the vehicle? I mean, you could wrestle your way through the window, but some cars you really don't want to do that on. But that's a good point. It could be. I don't recall any of them having that particular issue that I've come across or we've come across in the shop. And unfortunately, I've been around, or fortunately, I've been around for a while. But it's a good thought. I understand where you're coming from.
Steve asked, when headlights were turned on, the Power Probe tool only showed 175 milliamps. Is there some kind of conversion that needs to be done? Or is that just inaccuracy?
Yeah, I don't think that's 100% accurate. I know it does count up, because think about what the headlights would pull. You know, if you looked at the meter before with the amp clamp, you've seen the draw was quite high when we shorted the alternator thing out. So I did not read the directions on the Power Probe thing. Maybe there is.
I know they want, for that to be perfectly accurate, they want the battery disconnected, and it'll give you.
Okay.
So I don't know what they're able to.
So Bill brought up a good point. You know, just as a demo today, but they, according to Power Probe, the battery should be disconnected, you know, to get that actual reading. But then how does the...
Because it's still supplying the power.
Oh, because
but
it
just
supplies it
going
in.
through.
Okay.
But I don't know, I don't know why it would.
Yeah. So if Power Probe is correct, I'd have to do more research on that. You disconnect the battery. Its internal battery supplies the power in there, and it would give you a more accurate reading. Because we know each headlight got to be at least 5 amps, and it did not pull 5 amps. Okay, so we're very good on that.
What differences are you seeing with BEVs and parasitic drains?
Okay, so high voltage vehicles, I don't think we've had all that many. It's not like it can't happen. You know, your 12 volt battery, or nowadays anything that's an EFB, enhanced flooded battery, used on start stops, or lithium or AGM, the glass mat batteries, they're going to be about 12.9 to 13 volts. Haven't seen much of a problem with them. And be careful out there, everyone. There are lithium batteries that look exactly like AGMs. You know, our battery, the higher end, newer one from Associated, does lithium ion batteries. So be careful, don't just throw a battery charger on there. But I have not come across, and I don't think I've seen anything that you came across either.
No, not on high voltage.
Okay, so far nothing, but good question. Anything else there?
Thank you for a great training. Can you please repeat why the fuses will blow in a BMW, Subaru, or Toyota?
It's just on those particular cars, when you put in those battery saver packs like we have into the OBD2 connector, it's a 6 amp circuit, And a lot of times BMW may pull more and it seems to pop the fuses. That's just something, I never dug super deep into it. You know, BMW does weird stuff. A lot of the Euro cars do. Look at that Volvo example I gave you, you know, killed the battery. So you need to really read up on it if it's causing a problem. But I could tell you, you know, it's better to go to the jumper lugs on a BMW to keep it alive. Don't go in with a 16 pin connector. But this did work. Bill did use it because it was one of our commercial neighbors over here's car. So I figured if it's going to blow, we'll blow Bobby's fuse and we'll just give him a new one. You know, it would be on us. But I wanted to see if it would work because that is a problem. And the first time it happens to you and you don't know about it, that will shake you a bit. Anything else, guys? We got a couple of other things to finish up before we call it a day.
Someone asked what the part number was on the thermal, the snap-on thermal.
Yeah, if you can read it.
Where are we at here?
Yeah, this is one of their latest, greatest ones.
Yeah, this one is EETH 310.
And it does video. If you've seen some of the other videos we've done, we could record it, we could put it on the big Zeus tower. It's pretty neat. It's a very nice one. We have a way more expensive one that you've seen us use on the BMW, but you don't need to spend that type of money. And in full disclosure, you know, I got that from doing work with General, which was part of Fluke, you know, but you don't want to spend 30 some odd $100 on that. That's like insanity. Like I said, you can get them somewhere for about $500. I know the one from launch, really, really good. And thank you, Bill, because we'll finish up here. Let's go over a couple of things before I let you go. Tomorrow, the heavy duty. This is my buddy Swede, if he's still on. So the heavy duty lunch and learn is on heavy duty steering systems, essential maintenance, service and repair. It's 12 o'clock tomorrow. Coming up, there'll be a 2-hour for pay, $40 for a heavy duty brake class that Swede will be doing, okay? And some other ones that we'll be announcing. Excuse me. Swede and I, end of May, early June. And yes, Swede, I know I owe you dates. Now that I'm not traveling for 8 weeks straight, I will get you those dates. We're doing a heavy duty class up in the Buffalo area. It's hands-on, 2 days, covers 134A and 1234YF and a whole bunch of stuff. So you can reach out to me or Swede, and that'll be coming up shortly. One thing I'll be doing here, another Dorman training class, eScan scan tool class, eScan from A to Z. What's covered in this 4-hour hands-on, unique features of the eScan, sharpshooter resources, accessing the 10 modes of OBD2, using eScan to solve drivability concerns, and more. Cost $250, handout and food limited to 12 people.
When is that?
That is, oh, I don't have the date. I know it's coming up.
I think it's May 7th, possibly?
Yeah, I think Dorman may be right. Somewhere in May, we'll put it up real soon. Sorry about that. I didn't think I seen the date on the Dorman website. But it's coming up soon right here in Mayapack. You could reach out to me. I'll get you the date. Limited to 12 people. We'll be on car. If you guys have been here before, I got monitors on both sides so you don't have to look over my shoulder. And you'll learn some really good stuff and good features about the eScan itself. A great tool. And there's other classes. Ken Zanders will be doing LabScope and stuff in the Chicago area. So look for more stuff coming up on the Dorman Training Center website, including there are subscriptions now that you can get a whole bunch of different videos. And tonight I am doing the Snap-on LabScope. It is a 2-hour webinar tonight from 7 to 9 Eastern Time. If you haven't signed up, I know we got a bunch of people on. It will be live demonstrations on setting up your Snap-on LabScope, how to get the most out of it. So that'll be tonight. I do that. It's going to be a long day for me. And if you have any questions, I do want to thank you for coming out. I appreciate you all. There's some survey things here. What are you looking for, that model number again?
Yeah, gentleman wants the model number. I can't find it.
Give me my glasses and I can
Where is
find it.
located?
Model number should be here on the side. Pop those glasses over there.
Somebody wants to know how you work on cars if you can't see.
I have a
Very
problem.
difficult.
I have a problem
Right here.
working on cars right now, not seeing. I have a medical issue that I hope will be resolved in a week or two. Okay, so this is model number
I couldn't find it.
EET. I think that says
Let me see, I could probably see it better than you.
1130 right here.
1130.
You double check that right there.
EETH
Oh, well,
310.
close. I only see out of one eye, so that's close enough.
There you go.
Well, thank you guys. We appreciate your output. If you think it was good, type in that letter Y. If you think it was a waste of your time, type in the letter S for it sucks. Okay. But again, we try to come up with. I've been doing these for quite a few years now. I keep coming up with different things. We will be featuring a new scan tool that is the Hyundai Kia Genesis tool and does some other Asian manufacturers as well. I'm not done playing with that. We also have some top-down stuff that we'll be doing in the future. Next month, I think we'll do a AC one because it'll be AC season and everyone wants to get ready for it. Things that you need to know about your machine, things that you need to know about vehicles, and some of the issues out there. I was doing, for example, a hands-on class out in Indiana, and their machine had software that was faulty from Robin Air. It was allowing them to pull refrigerant in a 1234 YF machine that was not 1234 YF. It's supposed to stop the machine and just blow that off and not put it in the tank. It was putting it in the tank. So you need to check your machine out, and we'll go over a lot of that stuff next month on the Dorman Lunch and Learn. We'll have that date out probably within a week or so, and we'll take it from there. So thank you again. If there's no further questions from New York, I am G. Truglia, and have a great month, right? Happy April and happy May coming up. Thank you again. Don't forget Sweet tomorrow. Take care.